Okay, some of you have been asking me to do this because of the assessment or the test, and because we've done just like 2 chapters of that whole topic, and then we had the assessment, and some of you were absent, and so well, I've decided just created this video, and so it will just help. Okay, final exam is coming up anyway, so some of these questions are really not that difficult. It's based on some prior knowledge that you've picked up either this year or last year, and so let's dive into it. I think I'm going to break the video into 2 different parts. The first part is just about the triangle. The second part is about the circle equation. So we actually will break it into 2 parts, so you can watch it separately. First thing come first, the biggest question most of the time people ask is, how can we find out if that triangle is a right angle triangle or not? It's not really just by guessing. It looks like it, therefore it is. It's normally not the argument to go. And so in this scenario, there are 2 methods. There are actually 2 methods doing this. One is easier while the other one is longer. It depends on whichever one you fancy, I would say. So let's do the first one. The first method has everything to do with something you learned last year called slope. So basically, the first method is you're trying to find out the slope of 2 lines. Let's say the slope of AB and the slope of CB or BC. You want them to have the negative reciprocal. So let's say if I have the slope AB is 1/2, then you have the slope BC as -2. That's the negative reciprocal of each other. Then you'll get that. Another thing is, depending on the textbook, some of them will say the slope of AB multiply the slope of BC, you're going to get -1. It gives you the same effect as perpendicular lines. So let's try this. Let's try this and see if it's 90 degrees or not. It does look like it, and just see if it's going to be the case. So A, I have, let's change it to another color. Let's not have it that messy big as well. So A is 1, 1. Always write down those coordinates. B is 5, 1. C is 5, 4, isn't it? So you have these 3 coordinates. You're trying to find, obviously, you are not going to test this corner, you're not going to test that corner, because this one is the most likely to be 90 degrees. You're going to find the slope of AB, and you're going to find the slope of BC, and you want to see if it's going to be negative reciprocal of each other or not. So we are looking for the slope of AB and the slope of BC, so we are going to move this a little bit further away. Slope, so I would normally put like M of AB. That basically means slope of the line AB is going to be 1 minus 1. There's not a 1. And then 1 minus 5. 0. Okay. Slope of BC is going to be 1 minus 4. 5 minus 5. Now this one will be undefined. Okay, it's like divided by 0. But hopefully you can see that. Basically, slope of A, B is 0, while slope of that is going to be 1/0. Whether we have a negative in front of it or not, it doesn't really matter. So this one is basically, one is a horizontal line, one is a vertical line, therefore you have that scenario. So this is definitely a right angle triangle. It may not be the most perfect example because, you know, the 0 and infinity kind of throwing us off, but it's also a good reminder. Okay, for a horizontal line, the slope is 0. For a vertical line, the slope is actually infinity or undefined. That way, they pair up as the 90 degrees. So let's just create a new one. Just don't want you guys to get confused. Let's remove this. Let's draw another one. Just very randomly. Delete that. Delete that. Let's just draw a shape that kind of looking like, I would say, I'll try my best to draw one. Okay, let's double check and see if it's way on it. No, so I need to move this a little bit. I want to move this a little bit. Maybe move it over here. That does look like 90 degrees. So let's try that. I don't know, I just draw it. And because this one is not going to be horizontal and vertical, so let's try and see if this one is 90 degrees or not. I randomly draw one. So again, it's going to be testing the AB and BC. AB and BC, I might as well just write the coordinate over there so I don't take up space. A is going to be 0, 2. B is going to be 3, 5. C is going to be... That's not a very nice number though. I'm sorry. Move it to here instead. But that's why you should be a little bit more prepared than just wake up and do these kind of things. Paste. So this one will be a little bit better. Just like before, we're gonna lock this in place, and then we're gonna put down 0, 2. This is gonna be 3, 5. C is gonna be 6, 2. So we are testing the slope over here, testing the slope over there. So with the point, the slope of AB is going to be 5 minus 2, which is 3. 3 minus 0, which is 3. Nice. Is going to be 1. And then the slope of BC is going to be 5 minus 2. And then 3 minus 6 is negative 3. Good. Negative 1. So that is definitely negative reciprocal. And we can also check it, like I said earlier, some textbooks like to multiply these two slopes together to get negative 1. So basically they will test this. AB times M BC. So we get 1 multiply negative 1, so we get negative 1. Therefore, that is a 90 degree. Okay, so that is kind of the slope method. Is really not too bad. And then I want to talk about another method, because when I was grading the extra credit you guys did yesterday, there was another method, and some of you actually were using that. I want to clone this page. So the other method is actually related to Pythagoras Theorem. And if you remember what Pythagoras Theorem said, if you have a 90 degrees over here, then AC square is equal to AB square plus BC square. So if we have a 90 degrees, so that is the test we are going to do. So AB square plus AC square. Okay, now this method is going to be a little bit longer because you have to use the distance formula. Or you have to count boxes. At least the horizontal line is not going to be too bad. The AC is 1, 2, 3, 4, 5, 6. So AC is square is just going to be, well, let's just put an AC. AC is just going to be 6 units. So 1, 2, 3, 4, 5, 6. That's fine. We are going to find the AB, the distance. So AB distance formula basically says you have a square. The distance between the 0 and 3 is going to be 3 square. The distance between 2 and 5 is going to be 3 again. So 9 plus 9 is 18. So AB squared is equal to 18. I'm going to keep that over there because my equation is going to use AB squared. Let's find BC squared then. That should be a B. BC squared is just the distance formula. The x values difference is 3, while the difference between the y is going to be 3. That will be again 18. So let's go back. We are going to plug everything in as well. AC squared is going to be equals to 36. So we are going to plug this 3 data back in our Pythagoras theorem and see if it come out the way we expect it to be. So AC squared is going to be 36. I'm questioning this, so I put a question mark right next to it. AB squared is going to be 18. BC squared is going to be 18. So on the right hand side of the equation, I get 36. So there you go. So if you're using this, they would like to use it encoded by the converse of Pythagoras theorem. Your triangle is actually a right angle triangle. Okay, so there are 2 ways to go about. Of course, the slope is way easier, I think, but it's up to you. It's just pick one of the methods that you fancy and use them accordingly. Okay, and then this video is longer is just because of my lack of preparation in the beginning. Otherwise, it could be done in like 6 minutes. It's my fault. The other part is categorizing the triangle. So there are 3 types. Equilateral means all 3 sides are the same. Isosceles means only 2. Scalene basically means all 3 sides are different. So in that chapter, there are few scenarios where you have to classify if a triangle is one of these. Of course, you need to understand what that 3 terms mean, but once you understand it, it's really not too bad. So because we are all talking about the length of the side, it's always about, well, if this one is equal to that one, then we have isosceles. If this one equal to that one and that one, then we'll have equilateral. It's always about, can we find the distance of the side? So distance formula is going to be the key for this topic. So I want to find out AC. Let's put down the coordinate first. This is going to be -3, 1. That is going to be 0, 4. That is 3, 3, 1. Okay, just 1. So finding the distance, just like before, AC squared is going to be the difference between 0 and -3 is going to be 3 squared. Okay, between -3 and 0, the distance itself is the absolute value of -3, so it's 3. And then you have another 3. I think I kind of draw the same triangle like before. This is going to be 18, so AC is equal to square root of 18. Okay, find that first. In this kind of practice or this kind of activity, it is nothing wrong to find all 3 of them. You know, not until you find all 3, you really do not have the whole picture. So after that, I'm going to find AC. AC is the one down here. The difference of the x value is going to be 6. Between -3 and 3 is going to be 6. The difference between 1 and 1 is 0. So that's going to be 36. So AB, I'm sorry, it's too early. I shouldn't do this, but I want to have my Saturday, instead of doing this. So square root of 36 is going to be 6. And then after that, you have BC square. BC square, the difference between 0 and 3 is going to be 3. The difference between 1 and 4 is going to be 3. 18. So BC itself is going to be square root of 18. So with all three number, then you can compare them and see what I have. I have a pair of them the same, therefore it has to be isosceles. So if the three numbers are different, you have your scaling. If all three numbers are the same, you have your equilateral. This kind of question can also combine with asking you if this is a right angle or not, just like what we did earlier. And that two triangles basically are the same. Oddly enough, I just did a translation. Okay, these two triangles are exactly the same. It's just a translation from one point to another one. So that was the testing of triangles, and I think it's extremely useful, and it does use most of the topic that you guys did either this year or last year. It's just Pythagoras Theorem and slope, both of which were from last year. Distance formula is exactly the same as Pythagoras Theorem anyway. So that's all I have for this, and I will do the circle formula right after this. So bye for now.